Going through your revision booklet, alright? So before I go through, I want to say that there's a lot of room for improvement. Now, I want to go through some general strategies before we even jump into the questions so that we are all on the same page and you get a better understanding of what I'm trying to say when I go through the paper. Okay, so one of the main things that you need to note is that you should actually try to identify the topic. Okay, before you jump into it. And then you need to annotate the questions. Many of you, your question statements were so clean. Highlighting keywords is not good enough. You need to annotate. When you annotate, what am I talking about? I'm talking about using arrows to show trends for your data table. Okay, arrows to show trend. Okay, I want to see your CV and your MV. Okay, so this can be found in the aim, in the problem statement, and even at the table. Okay, if it's a table that is given to you or a graph that is given to you, you have to annotate your change variable and your measured variable. And always remember this, okay? Your change variable is the one that affects your measured variable. It is what it is. It cannot be any other way. It cannot be the other way around. Okay, so all these annotations must be made. Okay, next. This identifying topic is very important because it also tells you what are the common concepts tested. Right? Think about it. If it's a question on photosynthesis, then it will actually be factors affecting rate of photosynthesis. It is what it is, what? So factors affecting rate of photosynthesis, I already teach you already. Write down the word equation for photosynthesis. Later on, I am going to write it for you. In fact, one of the strategies that I teach my students is to write down the word equation for photosynthesis and respiration right at the start of the paper. So when they're answering questions on photosynthesis and respiration, alright, they actually can make reference to the word equation so they don't miss out on anything. But of course, most students always have issues following my instructions and they will leave out one or two important key points, causing them to lose unnecessary marks. Okay, so I really would like to encourage everyone to listen to me. Then after that, you need to go and memorize standard answers. I'm not teaching you to just memorize for the sake of memorizing, but because you are P5, it's the first time you are sitting for a full exams, you need to know what are the demands of certain common questions. And the questions are repeated. When I looked at your paper, I already know. Okay, you have forgotten what are the key requirements of key concepts. So this is what you need to do. Okay, then after that, other strategies will include things like, for example, using your CEO, okay, or your CERU. Also, you have your cause and effect. Answering strategy. This is how you need to actually write your answers. What is the cause and then what is the effect? And one other thing is to flip the question. So what is flipping the question? So for example, right, they ask you, why must you use certain thing? Or why did John do this? Why did Sam do this? So ask yourself, flip the question, what if Sam does not do this? What if John did not use that? What would happen to the experiment? And then you will go, aha, that is the answer. I will show you how to do it. Okay, so without further ado, let's start off with the first question, okay, so that I can show you what I meant. The diagram below shows Peter and Mary playing table tennis. It was observed that Mary's heart rate. So I said to identify topic. So this is what? Circulatory system, isn't it? This would hint to me that it's got to do with my circulatory system. It is what it is. And straight away in circulatory system, because we have practiced so much, okay, unless you're saying that I didn't teach you anything, cannot be the case, we've gone through this so many times. We are looking at what? How does, food substances get transported? Right or not? So basically, okay, when you look at this would hint you already, and then I'm also thinking of what are the organs involved. Okay, such as my heart, my blood vessels, my heart, my blood vessels, and my blood. These are the three things that I should be thinking of. Right? It is what it is. Okay? Now, playing table tennis. So this is a form of exercise. So we already know got circulatory system, got exercise, got heart rate. Isn't this the very common question that we always talk about? Asking us why do we think that heart rate will increase when intensity of activity increases. Okay, so before I go on, alright, okay, you may have your snacks quietly after I finish this question. So you do not need to ask me. You may have your snack. Finish it as soon as possible and don't make a sound. So basically, after this question, Fang Hao Ling. So look at it. What are my standard things? So a lot of you forgot the pump blood. So already tell you increase already. If you tell me heart rate increase, don't give you any mark one. So you must say heart pump blood faster. So remember, blood was one of the components of the circulatory system. For what? What is the main function? To transport more digested food and oxygen. Please don't keep telling me what to the rest of the body lah, to her body. She is playing tennis. So the main idea is it's an exercise. So will be to muscle cells. Okay, why do you want to do that? For faster rate of respiration to release more energy. Okay? If you want, which I'm not going to write down, to meet the increased demand of exercising. Okay? But I'm not going to write it down because that's optional. At your level, no need. But when you go to secondary school, you will need to do that. Then after that, the final marking point, you have to talk about the removal of carbon dioxide. So carbon dioxide and waste products are also removed at a faster rate. From where? Okay, from her body cells or her body. Okay, so they will be transported to the lungs or transported to the skin to be removed, depending. Okay, so this is a 2-mark question. Half mark, half mark, half mark, half mark. Okay, you have to memorize this. Okay, this is a common exam question. It is what it is. It is a very common exam question. We've done so many papers. Then, in fact, the paper you're doing right now, isn't it a past year paper? It is what? Okay, and we've done it so many times in our practice paper. It should be at the back of your hands, right? It is what it is. So the next part, this is a table. The table below shows the change in Mary's heartbeat while playing table tennis over a period of time. So this, okay, is actually your change variable. Annotate change variable. This has to be your measured variable. Draw arrows. This is actually increasing. And this is actually increasing also. So remember, I told you need to talk about how change variable affects measured variable. So from here, an increase in duration of Mary's playing will increase in the number of heartbeat per minute. Copy, cut, and paste. Don't go and invent your own label. Write it as it is. It is what it is. So it will be as the duration of Mary playing table tennis increases. Her number of heartbeat per minute increases. Okay, don't go and invent your own label and don't be lazy. Some of you just go, as the duration increases, heartbeat increases. Excuse me, heartbeat increases and heartbeat per minute increase, two different things, okay? And duration of what? Duration of Mary walking, sleeping, I don't know. So my main concern here is, I told you all before, just copy the table headings, but you all are not listening to me for some reason. I don't know why. Yes, I'm putting it on recording so that you know I said that. And then exam time, I want to pull back all your papers and then I want to show you all. Next. The diagram below shows how two body systems, R and S, are related to each other. Name S. So you look at S, no? What happens is that, what is going into S? Okay? What is going into S is actually your inhaled air, and what is going out is your exhaled air. So this tells me that your system S is actually dealing with, okay, different type of gases. So in this case, that will be your respiratory system. Okay, now strangely, a lot of you fail to recognize that they're asking for a system. You gave me organs instead. A lot of you tell me it's the lungs. So this tells me that you did not understand the requirement of the questions. Hello, system does not equal to organs. So organs that are in the respiratory system include things like your nose, your windpipe, your lungs. But no, they're asking for the system, which is made up of the different parts. State one difference between inhaled and exhaled air. I have mentioned this 10 billion times, but yet you choose to ignore me. I say before, when asked to compare, you must always talk about the same. Comparison. You cannot make it different. So some of you will go, oh, inhaled air is rich in oxygen, but exhaled air is rich in carbon dioxide. Who's to say that exhaled air cannot be rich in oxygen as well? If you say that, that's wrong, because it can also be that exhaled air is rich in both oxygen and carbon dioxide. So you have to make the same comparison. I have mentioned this umpteen time and highlighted this, underscored this, but yet you choose to ignore me. You are digging your own. So please, inhale air. Has more oxygen compared to exhale air. That's it, full stop. I'm just talking about oxygen. It is what it is. I don't need to tell you other things. So if you want to talk about carbon dioxide, then it's the other way around. Inhaled air has less carbon dioxide. Okay, so very quick revision. So this one is less carbon dioxide. Okay, you don't want less carbon dioxide, you can also say, okay, don't put water vapor, don't put temperature. Some of you put temperature, it is wrong. So some of you say that inhaled air is actually, no, exhaled air is warmer than inhaled air. That's not true. What if you are, okay, in a very warm country, right? Sometimes in Thailand, I cannot remember when, I think it was last year, there was a heat wave. It touched 40 over degrees Celsius. Your body temperature is only 37 degrees or thereabout. How is that possible? So don't go assuming things like that. Next. The diagram below shows how Suresh in a kayak, in order to move around water, he needed to exercise his arm. Describe how oxygen from the surrounding reaches Suresh's arms when he breathes. Hello, the keyword here is describe. So once again, ask yourself, what topic is this on? The topic is actually respiratory system and circulatory system. This is a combination question. So you have to talk about both. So they describe about reaching. So reaching means must be from one part to the other part, right? So it started off from oxygen in the surrounding air. So the first part will be oxygen. From the surrounding air enters the nose and passes through no need. Oxygen from the surrounding enters the nose and passes through the windpipe into the lungs. Okay, so this part itself, where are my marking points? Half mark for enter the nose, half mark for passes through windpipe and into the lungs. Okay, any part missing, you don't get the other point actually. Then after that, what happened? From the lungs, then the story must continue. It becomes circulatory system already. So you will say oxygen will then pass and dissolve into the blood stream. Okay, bracket blood. You can do that. So bloodstream is talking about the flow of your blood. Okay, yeah, you dissolve into it, it's true, but it's actually the blood cells, red blood cells itself that binds to the oxygen. Okay, oxygen is then carried by blood, or the heart pumps blood to Suresh's arms. Delivering the oxygen. So because it's a description question, you are required to write from point A to point B to point C to point D. So if you're not so sure, ask yourself this question. Okay, how do you get from school back to home or home to school?
No, I take a bus.
So basically, this is what you need to do. Okay, the heart needs to be there because it is part of the circulatory system. It is the central part of the circulatory system. So when in doubt, you have to mention about the heart. In fact, when you're in doubt, mention all three parts. You can even put in the part about blood vessels. So where to put in blood vessels here, lor? Okay, oxygen will then pass into the bloodstream. Okay, in the blood vessel. Next. Okay, I'll pause here for a while. Seems like some of you still need a little time. Alvin. Okay, moving on. Alright, the diagram below shows how plant W and the magnified of its fruit. So remember I told you, it could be fruit, it could be seeds. Sometimes it's the whole fruit itself, which I told you already. Based on the observation of the structure of the fruit, what is the dispersal method? Okay, so based on this is actually your wind. Now how do I know that? Because of this part over here, this is like a wing-like structure. Now I know that some of you would say that, oh, this is like a feather-like structure. It's fine, we will accept it. Okay, but generally for wind dispersal, when in doubt, just use the term wing-like structure. Because when you think about it, maybe each part of this is like a wing, something like that. Or wings are meant to help things float or fly, so wing-like structure is fine in general. Okay? State one characteristic of the fruit. Now, this is the issue. A lot of you say things like, oh, it's very light. Light as in, it doesn't weigh a lot. My question is, you cannot tell from the diagram. Did they give you a weighing scale? And then you put the fruit on it to show you how much it's weighing? No, right? So you cannot say that. So you need to say that it has feather or it has wing-like structure. Alright, that's it. And you need to state the obvious. Isn't this the obvious that it has a wing-like structure? Next, explain why disperse the seed further away. So granted that I know that this is seed dispersion, I told you many times already. There's only one reason why. Okay, but there are two parts of it. The first is to avoid overcrowding. You do not want overcrowding. And then after that, you must explain to me how does that avoid overcrowding. So it's about reducing the competition for your light, space, nutrients, and water. But guess what? Some of you made the taboo mistake that I tell you cannot make. You say compete for food. Excuse me, the plant is able to make its own food. It cannot compete for food. But yet, when I look at your answers, I have people competing for food, which I told you not to. Remember, I said that this was a common error. Don't do it. On top of that, many of you say reduce competition for oxygen. Excuse me. This is another one that I told y'all cannot write. Because it's negligible. There's so much air in the atmosphere. So you cannot mention anything about competing for oxygen or carbon dioxide. So you take a good look at your own answer and you ask yourself, why am I making all these common mistakes? And how would you feel when your results come out and you make the same common mistakes? So first thing, this is to prevent overcrowding, 1 mark. Second mark, reducing competition with parent plants. You cannot compete alone. I like how you all just go, reduce competition, but I don't know with who. For what? I say must mention 3 items out of the 4 minimally. If you're very good, mention all 4. The 4 would be space, light, nutrients. Oh no, don't put nutrients. Minerals. And water. These are the 4.
Teacher, is it overcrowding or is it prevent or reduce?
Prevent. Okay? Moving on.
No.
Quickly. Anyway, you shouldn't have to copy word for word. You should understand what I'm saying. Don't even need to copy. Right? Common question what? Next. 4 parts of the plant. Draw arrows to show how food is transported in a plant. So remember, the origin of food is actually the leaves. It's made in the leaves. So it must come from the leaves. And then how does it get to all the rest of the different part? Through the stem. The stem will then deliver it to the flowers. Okay. The stem will also deliver it to your roots. Isn't it? Next. The diagram below shows a plant with only food carrying tubes. When I see the word food carrying tubes, straight away I know that this is transport in plants. Right? And when I know that it's transport in plants, the first thing that jumps to my mind will be things like my xylem and my phloem. For those of you who don't know what are these two, it's okay, secondary school term, but I always teach you, this is your water carrying tube and this is your food carrying tube. Okay? So basically, all this should come to my mind. And this is a common exam question. I've revised this with you multiple times already, right? Revise already cannot, I even tell you what are the scenarios. But yet, you all are not making sense. Let's go. Take which of the following would happen after the stem sometime. So because the food cannot, the leaves are here, okay, so it will make food from here. Now what happens is that it cannot go beyond this point because the food carrying tubes have been removed. So all the food will be stuck here. Okay, it will be stuck here causing it to swell. No, I'm the one to care about the fruits. They didn't ask about the fruits. Answer to the question. To the question. Okay? So basically, what would happen to the stem after some time? So after some time, the answer would be the first one. Because all the food will attempt, or rather some of the food will attempt to go down towards your roots. Your roots is signaling, I need food. But guess what? No food. So more food as time goes by, more and more food, okay, will accumulate. The key word is accumulate. Okay, and causing it to swell. So what can your answer be? So when it comes to answering this kind of question, it's always about telling me which carrying tube was removed at where. So your first point, no need to say one, straight away. Food carrying tubes, I'm going to put phloem, was removed at the cart. First marking point. Cause and effect, right? Hence, food made by leaves or food from the leaves. You must tell me from where to where. Okay, very important. If you never tell me food made by the leaves or food from where, 0 marks for marking point for this, because it is a transport function that I'm talking about. Food made by the leaves cannot be transported below the cart. This is the best answer. Some of you say cannot be transported to the roots. Okay, fine. But my main point is still cannot be transported below which point? Below the cart. Second marking point. Okay? So then what happened finally? More food or more excess food, more food, this is my third marking point, accumulates. Accumulates where? You must tell me where. You say stuck. Food gets stuck. Stuck where? Stop where? Okay? At the area above, just above the cart. Okay? Done. Full stop. Where are my marking points? Half mark. Half mark. More food, half mark. Accumulates where? Half mark. It's not enough to just tell me store. Store where? Can store in fruit. Can store in leaves. Can accumulate where? Can accumulate in the fruit. Okay? So you can use the word store. No issues. But you must say more food is stored and stored where? Cannot say store in fruits because now you're describing the spelling. Okay, so read the question carefully. So if they ask you, why is it that the fruit grew bigger? Then it is more food get from the leaves is transported to the fruits, and then it accumulates there, making the fruit bigger. So answer to the question. And then this one is also very common if they test you on roots. You know, they'll ask you, oh, after a while the plant die. Why? So you must say, oh, the food, because the food carrying tube is removed, food cannot be transported from the leaves to the roots. Hence, the roots will have no food and it will die. And so when it dies, it cannot absorb water. The leaves will get no water, so it cannot photosynthesize. And then the whole plant will die. Okay? They will only test you that many scenarios. It is what it is. So go and revise on the various scenarios which I revised with you already. Okay, remember I put up a revision video sometime before your last WA, I believe. Go and revise that. State the function of the tiny openings. I also say many times already. When it comes to gaseous exchange, how many marks? Half mark. You have to tell me what goes in and what goes out. And the gases involved already tell you already. Include in your answers. But some of you still choose to just say gaseous exchange, or you choose to just say take in carbon dioxide. Then what about oxygen? They hinted to you that it's two gases. Still not good enough. So oxygen is taken in, and carbon dioxide is given out. Some of you, I don't know, I don't think your English is that poor. You just choose to not to do your work properly. You tell me carbon dioxide is taken out. How is it taken out? Taken out is wrong, you know. It's as if someone come here and then stole the carbon dioxide, literally took it out of the leaf. Next. Lisa potted a pot of berries in her berries plant. She exposed the plant to sunlight for 8 hours instead of 4 hours. So remember what I told you. This is actually your change variable. Produce sweeter berries. This is your measured variable. Right? So you have light here. So I see sunlight. Oh, it signals to me that this has to be photosynthesis. And learn how to spell photosynthesis. What is it?
Battery A is it during photosynthesis?
What?
Is it during photosynthesis?
Yeah. No?
Huh? Then photosynthesis.
Oh, sorry. Okay, you are right. My apologies. Okay, can we swap this, please? Okay, this should be carbon dioxide, and then this should be oxygen. Thank you, Jaden, for highlighting this. Okay, doing photosynthesis. Okay, anyway, back to what I was saying. Please learn how to spell photosynthesis. Can? Okay, because you will need to know, use it in secondary school. Make food in secondary school is wrong. Next. Explain how exposing the plant to 8 hours of sunlight. Excuse me, this question is on photosynthesis. And remember I tell you, in photosynthesis, they usually test you on factors affecting rate of photosynthesis. So which factor is it here? Light. Light, right? And what is increasing is increase of light. So some of you straight away went, oh, the plant can make more food. But why? Where's your cause and effect? Cause and effect, what's the cause? The cause of it is that now at 8 hours, the plant is able to receive more sunlight. So you must say the plant or the leaves. The plant takes in more light. Hence, it is able to photosynthesize more. Okay, you can stop here, half mark. But if you really want to make it like an A student, right? Making more sugar. Why? Because they say sweeter ma. So your sugar here will close the gap on the sweeter part. Actually, photosynthesis itself is already making food. You get full marks already. But I'm teaching you how to be A star students. Because you are answering to the question. And this is your cause. And this is your effect. But a lot of you, right, just say the plant can photosynthesize more, can make more food. Why? You totally ignore this, you know. Cannot. You must tell me more light. And please try to be more diligent during exam. Write a little bit more. Some of you really goes, it has more light, or there is more light. There is more light is different as in than the plant takes in more light. It is. There could be more light, but I never take in the light one. Right? Okay, next. Okay. So basically, Ali collected some pond water from 2 different ponds. Okay, I straight away know already, this is my CV. He wanted to find out how the rate of photosynthesis of water plant in each is affected by different types. Oh, this is my aim. Why? Because there is the word he wanted to find. So in my aim, I say again, all eyes on me. You will find both your change variable and your measured variable line. It is always like that. Okay, so within this line, can you see how the rate of photosynthesis? So this is my measured variable, or rather this is what I want to conclude. This is actually my change variable. He used identical lamps and placed similar types of water plants in each container. So both was placed in a dark room. Ali realized that his experiment was not a fair test. State 2 changes that he should make. Excuse me, it is to make. It is not just about the changes, what item to change. He must tell him how to make the changes. Some may just go the distance. Huh? What about the distance? I don't quite understand. Make the distance the same. Okay, so a lot of you will have realized, since the change variable is actually the pond water, everything else must be the same, including the distance from your light to the pond, to the beaker. This too is different. The volume of water should also be the same. The only difference is the type of water, or rather where the water came from. So some of you just went volume of water, distance. Huh? What about the volume? What about the type? You need to be specific. So you must say, okay, make the volume of water, okay, oh sorry, add, my apologies, to make it more clear, add 300 ml of water from Q to setup B. Okay, this will make it 500. 2. Decrease the distance of the lamp to the beaker by 7 cm in setup B. So that will make it 8 cm as well. So there are more general answers that we accepted. For example, okay, make sure the volume of water, volume of pond water in both setup is 500 ml. Okay, make sure the distance from the lit lamp to the beaker is 8 cm or 15 cm. So we are very explicit like that. Alright, I need the measurements. At least must say the same. And then distance, I don't say I never say. A lot of you distance, right? You don't care one. You just say, oh, increase the distance of the lamp. From where? Because you say increase the distance of the lamp, you know, it could be from here to here, from here to here, from here to here, from here to here. I don't know from where to where. Okay? Now, after Ali has made the necessary changes, what should he measure to compare the rate? Look here. Rate means time. Correct? So you know, most of you understand, if the plants photosynthesize faster, they will actually produce more oxygen, good for you. But a lot of you say, oh, measure the volume of oxygen. How? Excuse me, do you realize that in this setup, there is nothing to trap the oxygen? The oxygen will go into the atmosphere. How do you measure that? That is only plausible if you have a boiling tube, and then you know you can actually measure your O2 that is captured. But in this experiment, cannot. Because once the bubbles go up, it will be lost. So what you need to do is count the number of bubbles
for 1 minute.
produced by the plant every minute for 10 minutes. So what it means is that the whole experiment, okay, you will do for 10 minutes. Okay, and then after that, okay, you want to count, oh, how many bubbles it produced. Okay, there must be for every minute because wait correct? So I will pause here for today. I will continue. Alright, question 34C. Let's continue. So basically, added some fish, he observed the rate of photosynthesis increase. So I told you already, photosynthesis, they will always test you factors affecting rate of photosynthesis. So basically, you know that the factor that changed was the fish. And whatever the fish provided would allow rate of photosynthesis to increase. So there are mainly three things. Amount of water, amount of carbon dioxide, amount of sunlight. These are the three main things that will allow rate of photosynthesis to increase. So obviously it's not water, it's not light. So therefore you're left with carbon dioxide. Now this carbon dioxide, okay, you need to be cause and effect. How come the fish will give you more carbon dioxide? And your key idea here that many of you have missed is actually respiration. Okay, so you must say, the fish respired. I want to see this word and gave out carbon dioxide. Okay, so this is the cause. What is the effect? The plant is able to take in more carbon dioxide and photosynthesize more. Okay, there must be more and more. So what am I looking for? Respiration. If you don't have the word respiration here, deduction of half mark. Okay, look carefully. Next, Frank noticed that the green sign above was faulty. Only bulbs behind the letters XIT, okay, were lit. E was not. So what happened to E? So this is actually light bulb, right? So this must have fused, okay? And the fact that the remaining bulbs were lit up tells me that they were arranged in a parallel manner. So state how the bulbs behind the letters were arranged. Confirm is parallel. Okay, you all cannot spell parallel. Please learn how to spell. Explain your answers. So for this one, you need to memorize. This is a common exam question. You make sure you memorize word for word. You all cannot do this question. You know the answer, but you don't know how to phrase. So if that is the case, then please just memorize. It is what it is, okay? So the answers, okay, first part, parallel arrangement. The second part, okay, when one bulb fused, the other bulbs can still lit up as there is an alternate path for electricity to flow. Okay? Memorize this. it is what it is. You are very poor at answering this type of question, but you know the reason why, but you just cannot put it into words. So memorizing it is not like I'm asking you to memorize the content, okay, for the sake of memorizing. I'm asking you to memorize because you have issues putting it into proper sentence. Okay, so given that this is a common exam question, you should just memorize it. Next. Complete the diagram by drawing wires to show how the circuit was arranged. This is very good. Most of you followed my instructions. So obviously they were all parallel. So basically, when you draw parallel lines, make sure there are no gaps, which most of you did. Those who didn't, I actually highlighted. Okay? Alright? This is the main line. Okay? And within the main line, they all ran parallel. So it basically looks like this. Some of you use curvy lines, I don't know why, but okay. Use a ruler, please, and pencil. Now, in exams, you have to basically test out. So, for example, if this is fused, or rather, if this is fused, this is E, letter E, fused. Okay, so cannot, so this is not light up, but the rest will continue to light up because they all are closed circuit. So this will tell you that yes, this is correct. Next. Okay, I want to spend a little bit more time on this question so that you understand what are the requirements. So very good. I see an increased number of you using CEO, but still not everyone. Nelson prepared the following setup: circuit 1 and circuit 2. So this is circuit 2, this is circuit 1. He attached one end of a spring, okay, to a steel rod. Okay, so where is the steel rod? Steel rod is here, this is the spring. Okay? The steel rod could move about at fixed at point A. So it can go up, it can go down. Sorry, it can go up, it can also go down. Okay, this is the rotating point. When the switch was closed, bulb 1 light up. Explain why bulb 1 light up. Now, when I take this kind of question, before I even look at the question, don't say I never say. Straight away, I know I must use CEO. Okay? And then after that, from CEO, right, I know that, okay, let me do a very quick revision with you because this is important. I need to find some space. Okay, let's say here. CEO. C is your claim. Sorry, not your claim. Your circuit. Is it closed or open? E is your electric current or electricity. Can it flow through the circuit? Don't keep telling me flow where I don't know. Flow through the circuit. Your O is the outcome. Now the outcome, right, usually there are 3. Okay? The 3 will be, is the bulb lit up or not? Does something become an electromagnet? And the last one is a buzzer. Okay? Is it a bell or whatever it is? Okay? There are commonly 3 things that could happen. Now, if let's just say you talk about electromagnet, you must talk about what becomes electromagnet and check if it's check for coins, whether or not the item is an is a magnetic material, the one with the wire coiling around it. So in this case, it will be this one, correct? So I will check, is this actually a magnetic object? Yes, because iron is part of coins, which is I. Okay, and then after that, I must mention, attract what? Okay, what is it going to attract? Alright, so let's take, and then after you figure this out already, right? The next thing you want to do is, you want to run through the circuit to understand what actually happens before you even attempt the questions. So for example, when this switch is closed, so close, so then I would say, okay, close, so now electric current flow through. Now what happens is that this thing will light up. I also know that this becomes an electromagnet. Now when this becomes an electromagnet, because this is actually iron rod, so I know Mr. Chong said this one becomes electromagnet, means I have to talk about what does it attract. So it will attract my steel rod. So this will then go upwards. And then when this goes upwards, what's the consequence? Okay, the steel rod will actually touch the metal contact. This is the part that many of you did not say later on. Okay, that's why they drew it in such a way. Can you see it's touching? So once this is touching, it closes the gaps between these two. And then when that happens, now you can actually sound the buzzer as well, because the circuit is now complete. It is closed, there is no gaps, and electric current can flow. So now you have an idea of what happens. You then can translate this into your answers. Okay? So when the switch was closed, bulb 1 was lighted up. Explain why bulb 1 lighted up. Oh, it's exactly what we agreed on when we did our walkthrough of your electric currents. So now I just need to use what Mr. Chong taught on CEO to explain my answer. It is what it is. Alright, so firstly, close or open? Close, right? You don't have to tell me when the switch is closed. Did he say it's closed already? So you will say the circuit is closed. Okay, and electricity or electric currents can flow through it. So the it here refers to the current, the circuit. Alright, so that's it. Okay, how come down here we don't have O? Because the O is already here. You realize that the question didn't give you the O. So what is this? This is C and this is actually E. The O is already here already. Just in case you're wondering, how come I never follow my CEO? Now in exam, right, you should put CEO at your side and tick off. Tick it off. Okay? My formula, it is what it is, the strategy to answer. Okay, I've been teaching you electricity since don't know when, and I'm very consistent with my teaching. Go and watch my every video and it's the same thing. Okay, but the reason why you got it wrong is you're not following. It's as simple as that. When Nelson closed the switch, he also observed the buzzer would sound. Explain his observation. Well, this is exactly what I said also when we did our walkthrough, correct? Our walkthrough. Okay, so same thing. Now we need to translate this using this. So we would say that the iron bar becomes an electromagnet. Okay, and will attract. So attract what, right? I say already, the steel rod. And then what happened? The steel rod would touch or came into contact the metal contacts. And what happened? Because it came into the metal contacts here, it closed the gap. Okay, the circuit is now complete. It will close or closing the circuit. Okay, allowing electric current to flow through. Okay. All right. So I'm using CEO here. That's it. Next, Nelson replaced the steel rod with an aluminium rod. He noticed that the buzzer did not sound. Explain why. There is a lot of serious misconception. Ladies and gentlemen, my goodness gracious. Many of you actually told me that aluminium is not a conductor of electricity. That is wrong. It is wrong. All those who said that, raise your hands. Okay, I'm appalled. Read the question carefully. All metals are conductors of electricity. So in this case, why is it that steel rod, why is it that you replace steel rod, it will not work? And also some of you say the steel rod will not become an electromagnet. That is also wrong. And the other half of the class actually said that. Only a handful of you got this correct. So it's either you tell me that aluminium is not a conductor of electricity, that's wrong, or you tell me the steel rod, because aluminium is not a magnetic material, hence, okay, it cannot be an electromagnet. It's wrong. Okay? The reason why is that aluminium, it not being a magnetic object, means that it will not be attracted by your iron bar. It is your iron bar that is an electromagnet, not the rod. You need to be very clear. So because if you change this to aluminium, even though this is still an electromagnet, it will no longer be attracted. Because now if it's aluminium, it is not a magnetic object. You need to be very careful. And I think this came out for your WA, if I remember correctly, something similar. So you need to say aluminium is not a magnetic material. So cause and effect. So this is the cause. Okay, what is the effect? And the effect would be the electromagnet will not be able to attract the aluminium rod. Or you can say the rod, because there's only one rod. Okay, so this is your effect. So as you can see, I very clearly demonstrated to you throughout this whole entire paper how to use cause and effect. Cause and effect. So with all your questions, you should ask yourself, what is the cause and what is the effect? Where possible. It is what it is. Go back and keep watching my videos. Next. This question. John conducted an experiment in the room in the diagram. He placed material A at position X and recorded the amount of light detected by light sensor. He repeated the experiment for material B and C. He observed that no material was placed at position X. The amount of detected by the light was 2000 units. These are the results. So, first things first, whenever you're doing any experimental question, anything with data, whatever it is, first things, change variable, measured variable. I say many times. And whenever there can be a trend, you do the arrows up and down to help you decipher what is the trend. Now in this case, there isn't a trend, so it's fine. Okay? Then what is the aim? The aim of this, right, when you take a look at it, right, is to basically find out, okay, whether or not the materials, how much light they let through each of the different materials. Material B is opaque. Opaque means does not allow any light. No light, okay, to pass through. However, John was puzzled that the amount of light detected was 20 units instead of 0. So let's look at this. Okay, where did he conduct this? Okay, so he conducted it in a room. They never say a dark room. There is no dark room, don't have. So the fact there is no dark room tells me that, oh, there are other lights. Okay? And now what is wrong with this question? Or rather, what is the common mistake with this question? A lot of you tell me things like, oh, there's light in the surrounding. There are other sources of light. So what if there are other sources of light or there's a light inside the room? The key idea is you need to tell me the light sensor detected light from the light in the surrounding room or other sources of light in the surrounding room. So basically, if you don't put the word detected, okay, it doesn't matter. You understand? It needs to be detected. Okay, it has to be. It is what it is. Okay, so you say the 20 units of light detected by the light sensor or the sensor, because there's only one sensor, came from other light sources in the room. So take hint from the question stem. This is called the question stem. And then also, I say already, copy, cut, and paste the heading for your measured variable and your change variable. It is what it is. I say so many times already, but you all just refuse to listen to me. You all will go surrounding light and full stop. You all just threw away the detected by light sensor. Okay? Do you understand now? There could be other sources, but if your light detector don't detect it, it doesn't matter. It doesn't matter. It will not be reflected. Next. All these skills I'm teaching you is PSLE already. I'm not preparing you for year end, sorry, I'm preparing you for PSLE. Next. This one. John put up a puppet show for his son using two puppets below. Okay? Based on the results of John's experiment, which of the materials A, B, or C is most suitable to be used as a screen for a puppet show? Explain your answer. Now this is a bit more complicated. To understand this, you must first look at the situation. Okay? So they say the screen. So in the first place, I know you go by elimination method. Ask yourself, what happens if the screen is transparent? If the screen is transparent, okay, no. If the screen is transparent, okay, cannot. Why? Because you can see the father at the other side. You can see John. Right? Because you can see John, right? If it's transparent, straight away John will be reflected into the son's eye. Then what's the point? Can it be a puppet show or not? Cannot. So we know for sure transparent won't work. Okay, let's try. How about, okay, opaque. No light. Cannot also. Because if it's 100% opaque or blacked out, what do you see? You see nothing but a piece of screen. You cannot see any puppet, no shadows, nothing. It's just the screen. It is what it is. You don't see anything. You see one opaque thing here. Right? So cannot. You see nothing. So the only one that is plausible is that it needs to be translucent so that some light can pass through. So if I were to draw this out for you, this is the screen, okay, and then what happened is that, okay, this is the shadow. So the shadow is formed because the puppet at the other side is blocking the light, the path of the light. And then how come the other areas, these areas, This is the part where your light is able, some of the light is able to pass through. Right? That's why you can see some light coming through, isn't it? Okay? And it needs to be translucent so that it blocks some of the light in order to form the shadow. This is a shadow. Okay? And you cannot allow all the light. So therefore, the shadow can be formed on the screen. So based on illumination, it can only be a translucent material. And then you go back to here. Which one is translucent? Answer is C. Because they already say B is opaque. How come I know that B is opaque? Because they say here already what? B is opaque. There are a number of you who put B, okay? So basically based on this. And then after that, remember Mr. Chong told you this. If given options, A, B, C, and D for materials, okay, it is C, E, R, U. Make sure you check everything. So let's go. Let me revise. C is claim, E is evidence, R is reason, U is usage. Now, for evidence, do you change anything? Do you change anything for evidence? No, very good. I see that you all are shaking your head. Correct. You do not change anything. You take it as the data, as it is. As it is. Your R is where you look at your evidence and you decipher. Using your own scientific knowledge, you reason it out. Why is the case? What does it suggest? What does this suggest? Remember, I teach you very nice phrase. This suggests that, And then U is your application. Okay? How does it work? So for example, by using material X, which is waterproof, to make the umbrella, the user will not be wet. So that is the usage. So now let's craft the answer. So my C is actually material C. And then after that, my E, my evidence, okay, would be only C allowed some light, or you can say only, one second, let me think, how can I craft this? Okay, got it. Okay, only the light sensor for C detected some light. Right? I told you to copy exactly. So why light sensor? Because down here, amount of light. And please don't quote values. Quoting values is description. No, you have to tell me in terms of evidence. Okay? B is opaque. The 20 don't count. A is 2000. Detected all the light. C is the only one that detects some. So if you want to be clear, this one is all the light. This one is actually no light by right. Okay? It doesn't came. This is some. Okay? So, then your R. Okay, so what does this suggest? Okay, this suggests that C is translucent. Okay, then after that you go on to talk about the screen. Okay, so then you would say that U, okay, by using C, the screen can block some light from passing through. This allows the shadow of the puppet to form on the screen. Okay, allowing the sun to see the shadow. Right? Okay? So you think about it, if it's transparent, no shadow will form on the screen, only reflection. Right? If it's, let's just say, opaque, oh, don't even need to see. You can't, okay? You can't see anything, it's just blocked. Okay, next. Okay. Eunice set up an experiment as shown. She placed equal slices of cold solid butter on material X, Y, and Z. So your material X, Y, and Z would actually be your change variable, isn't it? Okay. She measured the time taken for the slice of the cold solid butter to melt completely. So if you realize here, right, the hint here is melt completely. It tells me that it's got to do with conductivity of heat. Okay, and then this is my change variable, and then this is my measured variable. So if I looked at it, right, isn't it looking at, you know, how well a material can conduct heat? So state the aim of Eunice's experiment. Now the problem of this is a lot of you understood, but you were not careful. You went to find out which material is a better conductor of heat. Cannot, because there are 3 materials. It should be best conductor of heat or worst conductor of heat. Okay? Or you can say that because time is involved, you can say that to find out how different materials affect the time taken for the solid butter to melt. Okay? To find out how different materials affect the time taken, okay, for the butter to melt completely. Okay? Change variable, measured variable must be inside the A. So this is your change variable, this is your measured variable. Next, explain how the butter on the materials melted completely. So you understand, melting is a heat gain process, right? So heat gain process means it must gain heat from somewhere. But a lot of you just ignore that fact, you know. You didn't tell me gain heat from where, just went gain heat. Gain heat and melted. Huh? But gain heat from where? I told you already, right? So the butter gain heat from 2 places. Either gain heat from the surrounding or gain heat from the material and melted. Half mark for telling me that it's a heat gain process, half mark for telling me where did the heat come from. Next, Eunice wanted to make a plate that would allow her to defrost frozen food the fastest. So defrost frozen food means that the frozen food must gain heat quickly, correct? So to gain heat quickly, okay, it needs to be on a material that is able to actually conduct heat very quickly. So how does it work? Let me explain to you. So from here, the one that I will pick is actually material Y. Because material Y took the shortest time for the cold butter to melt. So when you think about it in terms of food, okay, I'm going to be very realistic here. So this surrounding temperature of Singapore is about 31 degrees Celsius. Your frozen food is about 0 degrees Celsius or maybe even minus 3 degrees Celsius thereabout. So this is the material. So what happens is that, remember, it's a heat gain process. So basically air itself, is air a good conductor of heat? No, air is a very poor conductor of heat. It's a very, very poor conductor of heat. Okay? So therefore it's no good. You need your material X to be in contact with a material that is good conductor of heat. So conductor of heat just means that heat energy is able to pass through it very quickly. So this is the hotter region, right? So basically you're passing through material Y and then from there you're going towards the frozen food. This is how it works. Not this way, I mean, yeah, this way also, yes, but the purpose of this material Y is so that heat is gained quickly by material Y. And it's also lost quickly from material Y to your frozen food. So can you see it's actually from here to here. It is what it is. Okay, you have the understanding process. Who don't understand what I just said? All understand? So basically based on this, right, you go back to using this CERU. Right? So your C in this case would be Y. Okay? And then after that your E. What's your evidence? So material, so Y took the shortest time for the butter to melt completely. Okay? So the next one will be then reason. Right? So your R. This suggests that Y is the best heat conductor. And then U. By using Y, the frozen fruit can gain heat from Y the fastest and melt the fastest or defrost the fastest. Okay, maybe we use the word melt. And melt the fastest. Okay, and the keyword here is fastest, not faster, is the fastest. And I'm looking for gain heat from where to where, which I have been saying 10 billion times. But yet many of you have made this very serious, grievous, common error. Alright? So there is really nothing very special. I am following my own advice that I give myself to answer all the questions. Okay, next. Okay. Raju had 3 containers, PQR. Each container has different exposed surface area. He poured 100 ml of water into each container and left them in the classroom. Raju returned 5 hours later and measured the volume of water left in each container. He then recorded his observation. So very straightforward. Okay, This is on evaporation, and for evaporation they always test you on factors affecting rate of evaporation. So basically WET, wet wind speed, exposed surface area of water, and then temperature. So an increase in any of these factors will lead to an increase in rate of evaporation. So in this case, they are testing you on exposed surface area. So no need see already lor. This one has the greatest one. So this one must have the least. Okay? This one is the least amount of water. Okay? So basically the fastest rate of condensation, it should be R followed by Q and P. Why? Because P has the smallest exposed surface area. Okay? State the relationship between the amount of exposed surface area and the rate of evaporation. So this one is very straightforward. The greater the exposed surface area, please copy, cut and paste. The amount of exposed surface area of containers, the greater the rate of evaporation of water. Okay, it's just about copy, cut and paste. I stress again, especially those people who tend to short form and write in your own. Don't say I never say. I repeat until you don't repeat already. Next, other than the amount of exposed surface area, state two other factors. So there are many. So I'm going to tell you what is the first thing I'll look at. I will look at this. You all stated many other things that are correct, but don't you think you should look at these first? Right? So the two other factors that is the best answer would be wind speed and temperature. Right? But temperature of what? Don't just tell me temperature. So you can say temperature of surrounding. And then also you can say presence or absence of wind. Right? Or the wind speed. Anything to that extent. So I'm following my own advice that I give myself. I say evaporation always talk about factors. So if I have this here with me, I'm safe. So in exam you can write this down to actually help yourself to decipher the answer. It is what it is. Next. Okay, this question. Mrs. Tan noticed that after taking a hot shower, the mirror in the bathroom would mist up. You see the word mist. Straight away, it hints you to water droplets. And when you see water droplets, most probably it is got to do with water cycle. Right? Explicitly, condensation. Remember, water cycle is driven by two processes. You have your evaporation and then you also have your condensation. It is driven by these two processes. Okay? So you have to talk about it, right? Now, so explain how the mist is formed on the mirror. So mist is water droplet. And when I see water droplet, okay, basically, I know that they're asking me for condensation process. Now, in order for condensation to happen, you will need water vapor. Now, then the next question to ask yourself is, what is the source of your water vapor? Where is your source of this water vapor? Where? From where did this water vapor come from? Okay? Another thing, when it comes to condensation, you will need a cooler surface. So how do you determine which is your cooler surface? There is only one way. The cooler surface is where you will find the water droplets. It is where it is what it is. If the water droplet is in the air, the cooler surface is the air. That's why you see clouds. You see, like, you know, when you open your pot, you see this white mist. Don't tell me that is steam. I repeat, that is not steam. The white color mist that you see out from a hot boiling water when you open the pot of boiling water is not steam. Steam is water vapor. You cannot see it. It's actually very tiny water droplets. I want to revise on that in a while. So basically, where you find the water droplet, that is the cooler surface. So your mirror has to be your cooler surface. Okay, it is what it is. So first thing, let's talk about where is the source. How do we translate this into answer? So basically, there are two ways to go about doing it. Because it's hot shower, right? So if it's hot shower, you can say that, you know, the surrounding air actually gain heat. The water vapor gain heat. Or you can just say, very straightforward, just say that, you know, that warmer water vapor in the shower. That's it. Because literally the hot water that you're using will have transferred heat to the surrounding water vapor. Correct? It will heat up the air, right? So you can just say warm water vapor in the bathroom came into contact or touches with the cooler surface of the mirror. Lost heat and condensed into tiny water droplets. This is your mist. Now let's talk about the answer. How do I break down your answer? Now, in the first place, this is your source. Okay? Yes, marks is given. You have to tell me where does your water vapor come from. At this instance, there are quite a number of you say water vapor evaporated. Excuse me, your water vapor is already gaseous state. It cannot evaporate. Read your answer. Many of times, it is this kind of common question that gets you. Okay? Came into contact or touches with the cooler surface of the mirror. You need to identify. Lost heat, this is important because if you don't lose heat, you cannot condense. And why you need to say condense into tiny water droplets? Because if you don't say tiny water droplets, then how do I see the mist? Right? Which I've been trying to tell you all the time already. Next, Mrs. Tan installed a small heater on the surface of the mirror. So you think about it, this used to be the cooler surface. Now, no longer cool, right? Because of the heater. So now she said that the heater will heat up the surface of the mirror. So how it prevents the mirror from misting up? So remember, at first it was the cooler surface. And why it was the cooler surface is important is because it allows the heat from your warmer water vapor to be lost to your cooler surface. Because heat always travels from a region of higher temperature to a region of lower temperature. Now imagine, your mirror is no longer cooler. It is hotter, or if not the same temperature as your hot shower. So there's no more cooler region. Okay? Because of that, your warm water vapor, when it touches the mirror, it cannot lose heat to it. It cannot condense on it anymore. Right? And no water droplets will be formed. So cause and effect. So basically, you would say that, okay, the mirror will gain heat from the heater. So when it becomes, again here what happens? Cause and effect. And becomes what? And becomes warmer. Or temperature will increase. Then after that what? Less water vapor will lose heat to the mirror and condense, and hence less condensation. Sorry, maybe we change this, and condense into water droplets. Okay, so cause and effect. So what do I need to see? Firstly, I need to say gain heat from where to where. After I say gain heat from where to where already, you must tell me what's the effect. It becomes warmer. Then now the mirror becomes warmer already, what happens? Oh, okay, warmer means that now water vapor cannot lose heat or loses less heat to it. And so because of that, lesser loss of heat equals to lesser condensation, equals to less water droplets being formed. Alright, so we've come to the end.